Hi guys, I hope you guys doing good. So let's do section 2.5. Um, last in last lesson we learned how to sketch rational functions. Today we continue with differentiation. So far we learned one rule with differentiation, namely the power rule. Today in section 2.5 we're going to learn another two rules, the product rule uh, and the quotient rule. Right, let's focus to the board. Alright, so rules of differentiation. um, if f equals fx, no need to explain, I believe you guys understand this. F equals fx means f is a function of x, g is a function of x, and h is a function of x. We take this, means we take three functions f, g and h, all those are functions of x. Then power rule, we discussed this already. What power rule saying is, if fx is x to the power n, we can write the derivative. We write derivative in two different ways. We learned this last time. We can write it as df dx, or we can write as f prime, sometimes called f dash x. The derivative of f equal to n, the power comes to the front, x times power minus 1, n minus 1. That's the power rule. We learned this already. Today we're going to learn product rule and quotient rule. What product rule saying is this: if h equals fg, fg means f times the f multiplied by g, right? If you want, I put a little dot there. Writing this is same as write like this: hx equal to fx times gx. Clear? If h equals to function f times function g, we can write the derivative of h prime as, keep this in mind, this is the important thing. First function f times g prime means derivative of g plus g times derivative of f. Okay, let's see it again. Derivative of h, which is h prime, is equal to first function times the derivative of the second function plus second function times the derivative of the first function. Right? We're gonna do examples. Before we do examples, let's learn the quotient rule too. The quotient rule saying, if h equals to f divided by h, this is not n, this is h, equal to f over g, then h prime, the derivative of h, we can write as g f prime minus f g prime divided by g square. Right? Applying this is little bit tricky, right? applying this on examples is a little bit tricky. Let me tell you why. When we do this, the product rule, you see we have plus in between, right? Therefore, we can interchange these two terms. We can write this as the second term first, gf prime plus fg prime. Nothing wrong, right? But with the quotient rule, we have minus in between. Therefore, you cannot interchange these two terms. Means you cannot write this as fg prime minus gf prime. Understand? Therefore, this has to be in the same order. This, I tell you a way to remember. Start, when you're doing the quotient rule, start with the one in the denominator. Start with the denominator, right? Denominator times numerator, derivative of the numerator, minus numerator times derivative of the denominator. Just remember the start of the beginning. You start with the denominator and divided by denominator square. Clear? Okay, let's do an example. Now, I should tell you, when we doing examples, it could be one of these two rules, or we have to use combination of two or combination of all three. There will be another rules we learn near future. So we have to use one rule or few rules together, maybe all of them together, to solve or to find a derivative of a given function, right? It will be clear to you once we do examples, right? If fx equals this, find f dash. If fx equal to this, we want to find f prime x or f dash x. You know, we can write this as df over dx or f dash x. Sometimes it is good to write this thing as df over dx. But for the convenience, when it is not necessary, I write f dash x, right? Whenever it is necessary to explain like this, I use this notation. Yeah, I would like to remind you again, this does not mean d times. This means the derivative of fx with respect to x. This is what it means. This is not d times fx divide by no division. This is not a division. It's a line, division line, but it is not division. This is the derivative of fx with respect to x. You read this as dfx dx, right? Again, dfx dx. Alright, so let's find f dash x. What's the rule we using? The product rule. This is a product between two things, this times this. f dash x equal to first term times derivative of the second term. Let's write that. First term is x to the power 5 times d dx. I told you whenever necessary to explain I use this notation. Derivative of the second term. 2x plus 1 is the second term, plus second term times the derivative of first term. This is the first term and this is the second term. Two x plus 1 times d dx. Let me erase this part. X to the power 5. Okay, now let's do the differentiation. X to the power 5 times the derivative of 2x plus 1. 2x, derivative of 2x from last time, when 2 is a constant, x is the only variable, it is 2. 1 is a constant, derivative of constant is 0. Eventually I stop writing this step, derivative of constant, you should know this is 0. In this example I write it plus 2x plus 1 times derivative of x to the power 5 from last time, means using power rule, 5 comes to the front, 5 x to the power 5 minus 1, which is 5 x to the power 4. Right, if you cannot remember, refer to the lesson that we discussed about power rule. Okay, divide by, or not divide by, this is the power rule. Division comes with the quotient rule. So that's it. This time derivative of this plus second term times derivative of the first term. That's it. Then simplify this a little bit. This is equal to 2x to the power 5. 2 plus 0 is 2. That 2 times x to the power 5 is 2x to the power 5. We can distribute this. 5 times 2 is 10. X times x to the power 4 is x to the power 5 plus 1 times 5x to the power 4 is 5x to the power 4. X to the power 5, x to the power 5, combine like terms. 12 x to the power 5 plus 5 x to the power 4. Okay, that's it. You cannot simplify any further. This is the final answer. Clear? Let's go to the second example. This is the example 1. I'm gonna erase this. if f(x) equals 3x minus 2 over 4x minus 5, find f dash x. Now first look at the question. What this looks like. Is this a product? No, this is not. This is a quotient. Means a polynomial divided by another polynomial. So we have to use quotient rule. F dash x equal to, now let me write first term and second term. Find a different color. This is the second term. Alright, first term, second term. Or numerator, denominator. Let's use the quotient rule. Second term times the derivative of the first term. 4x minus 5. This times derivative of this. d dx minus first term times the derivative of the second term. Divided by denominator square. 4x minus 5 in the denominator, that square. Alright. Now let's do differentiation. 4x minus 5 times the derivative of 3x minus 2 is just 3 minus 3x minus 2 times derivative of 4x minus 5 is 4 divided by 4x minus 5 whole thing square. This is equal to distribute, and then combine like terms. 3 times 4, 12x be careful, you have negative sign outside. You may consider you multiply this parenthesis by negative 4, then you get negative times negative positive. Positive 2 times 4 is plus 8 divided by 4x minus 5 square. Now combine like terms. 12x, negative 12x cancels out. Negative 15, positive 8 is negative 7 divided by 4x minus 5 square. Okay, there we used quotient rule. Let's see another example. Looking for example from your book. Okay, let's do this example. I'm gonna erase this. This red area it gives problem. Let me erase it off with some water. Remember what we did in class? Alright, let's see if it works. Okay, let's see. Let's get the example from the book. X to the 4 minus 2x to the 5 plus 7 divided by 3x square. Alright, so now clearly this quotient, we can use quotient rule. There is another way. I'm going to show you that too. So let's, since at a glance this is a quotient, let's use the quotient rule. F dash x equals to denominator times the derivative of the numerator, 3x square times, now I'm gonna write the derivative of the numerator here, which is 4x to the power 3 minus 10x to the 4. Derivative of 7 is 0. I'm not writing it here. When the thing's complicated, we do simple simplifications without writing, because if we write everything it looks too complicated. Now this is denominator times the derivative of numerator minus numerator times numerator times derivative of the denominator. Numerator is what? This thing. I'm gonna write it here. This is the whole numerator. Now I'm gonna write derivative of denominator here. This is the derivative is 6x to the power 1. X to the power 1 is x, divided by denominator square. Without making mistakes with algebra, 3x square. Don't write 6x to the power 4. When you square this is 9 3 square, right? So if you think you're making mistake, write this step. Now let's do simplification, means distribute this. when we multiply, we add the exponents. X to the power 2 plus 3 is 5 minus negative times positive is negative 42x divide by what is this? 3 times 3 is 9. X squared to the power 2 is x to the power 4. Right? Combine like terms. 12 minus 6. Let's do the highest power first. Negative 30 positive 12. X to the power 6 negative 30 positive 12. Then x to the power 5 like terms. 12 minus 6 is 6 plus 6 x to the power 5 minus 42x divided by 9x to the power 4. Common factor, we can divide everything by, on numerator we can divide 18, 6 and 42 by 6. 6 is a common factor. And what else? X to the power 1, this is the smallest exponent, so 6x is common. Divide by 9x to the power of 4. Right? We can divide top and bottom by 3. 3 goes into both. 3 times 2, 3 times 3. One of the x's we can cancel out. We cancel out this 4 and we get 3 here. Right? So we get final answer. I write it here with a different color. No x cancel out. Negative 3x to the power 5 plus x to the power 4 minus 7 divided by 3x to the power 3. Alright. Alright. Let me show you the other method. I'm gonna erase this. I try to keep this answer to compare. Now, looking at this not always happen, but in this case we can separate this, means we can distribute this denominator under each numerator. What I mean is this: we can write this as x to the 4 divided by 3x square minus 2x to the 5 divided by 3x square plus 7 over 3x square. Agree? We can write this as this. Means if you look at this, since we have the same denominator, we can keep the denominator and we can combine numerators. We get this original expression. Now let's simplify this a little bit. This is, when we divide, we subtract exponents. This is x square over 3 minus 2x to the power 5 minus 2 is 3 divided by 3 plus this thing, nothing to cancel out, but we learned last time when we using the power rule, it is easy if we move this to the top, so we can write this thing as 7x to the power negative 2 over 3, right? Now let's differentiate this. This is equal to, now we can directly use power rule, nx n minus 1. This 3 is a constant. We can take this 3 outside and leave this 3 as a constant and do the differentiation as it is. Anyway, this 3 is a constant. We can say this is 2x to the power 1. Now since we differentiating, we have to write f dash x equal to 2x over 3 minus, let me sign this one. Right. 2x to the power 3. When we differentiate in this, we get 2 times 3x to the power 2. 3 minus 1 is 2 divided by 3 plus, differentiate this. Be careful, this is, we have constant 7 and 3. Now we differentiating x to the power negative 2. When we differentiate, we know the exponent comes to the front. Negative 2 x to the power negative 2 minus 1, n x n minus 1. Negative 2 minus 1 is negative 3. Okay, now let's do simplification. 2x over 3. This 3 to 3 cancel out, we get 2x square plus and minus is minus 7 times 2, 14 x to the power negative 3 over 3. We can leave the final answer like this. In algebra class, yes, you have to make all negative exponents positive, so you have to move this to the denominator. Here you don't have to do it. This is the final answer. But you see, at a glance you see, oh, these two different. What happened? Now if we get to the same denominator, I give you a clue. Okay, so you can leave the answer like this, but to get to this answer, we can write this as, we can move this x to the power 3 to the denominator, minus 2x square minus 14 over 3x to the power positive 3, right? Get it? I'm gonna erase this part on the top. We got f dash x equal to, now the common denominator is 3x to the power 3 3 times x to the power 3, multiply this, x to the power 3, then x to the power 4 minus, we got to multiply this by 3x to the power 3 5 minus 14. Right, now take 2 out, we get this, if you take out 2 as the common common factor, x to the power 4 minus 2 times 3x to the power 5 minus 2 times 7 divided by 3x to the power 3. This part you don't have to do it, you can just leave the answer we got here, which I underlined here. So in that case, what I'm trying to show you is, if you can separate this and get a polynomial without writing this as a quotient, do that. That's a easy way. Now in this way, you see both the answers are the same, so you don't have to use the quotient rule here. You can simply divide each term by 3x square and then differentiate, right? But it is not always possible, so practice the quotient rule too. So I think that's all about product rule and quotient rule. So as an example, I will ask you to do one of the questions here. Questions where you have answer. Do example 4 in 244. Page 244. Example 4. Do this and let me know how you're doing. Right? Email me. I expect to see email from you guys if you get this or not. Right? You have the answer in the book. So please let me know if you don't get the answer. I can do this example again. Means in the next lesson we can discuss this. Alright, so stay safe. Right? We'll see you again in another video. Right? Take care.